human-powered, some easy to do it yourself generators. Hey all, welcome to this video. It's about how to generate electricity with your body. A bit strange coming from me because I can only move my head. But I find electricity really interesting. It's been a journey for me because I didn't know what will work best. The goal is to charge a phone. How much energy do you need for that? And can you make it yourself? And for me it's all fun and interesting. But for some people on Earth maybe it's necessary because there's no electricity and even no solar, so maybe that will help them too. Okay, enjoy. What body movement can produce the most power? The most common options are using 2 legs, using 1 arm, and using just 1 hand. The order of power is clear, but how much power do you need? And does your generator need to be mobile? My goal is to charge a mobile phone from 20 to 80% in a minimum amount of time. My mobile phone has a battery with a capacity of 12.36 watt hours, but we charge only from 20 to 80%. And transferring energy is never 100% efficient. Let's make it simple. I will need to produce 9 watt hours. For in case you don't know, producing 9 watts for 1 hour is 9 watt hours. 3 watts for 3 hours, that's also 9 watt hours. But why make a generator yourself? You can just buy this one online. It is made for charging your phone. It is small, lightweight and cheap. So, we're done. Are we? No, let's test it. It is from China. Well, not everything from China is bad, but you get what you pay for and this was really cheap. I use this LED light as a test load. At 5.23 volts, it uses 1.83 watts. The little cheap generator should produce up to 3.3 watts, thus more than enough to power the LEDs. This generator promises a maximum output of 3.3 watts. First thing to check is the USB voltage. Should be around 5.1 volts. 6.4 is too high. Not a good start. As just shown, this LED light needs only around 1.82 watts. So that should be easy to power. Whoa, hold on. The voltage drops to 3.7. That's much too low. And the ampere is 0.5, no, 0.05. 0.19 watt. Reality check. We need to produce 9 watt hours at 0.19 watt. That will take about 47 hours and 22 minutes. Also, USB needs to be at least 4.75 volts. And will a phone wake up for 0.05 ampere? This generator cannot wake up this smartphone. Nor will the smartphone start charging while awake. This generator is junk! So, this cheap generator is useless. Just don't buy it. Is there anything good on the market then? Well, yes, I found one that's really good And, yeah, expensive. I don't know for who it was designed, but it feels like military quality. And it sounds like high quality Metal Gears. Let's compare. Why is this generator so bad? All parts are too small and of lowest quality. And why is this generator so much better? All parts are larger and of high quality. It's not just the size and quality, the better one also has more and different parts, for better safety and more functions. First conclusion is that hand power is useless. If you build a high quality tiny generator, you may reach 1 watt, that would still be next to useless. Disclaimer, I'm not sponsored by anyone or any company. All the stuff you see I bought myself. With that said, this is how to operate this good but expensive generator. First, you must set the output voltage correctly. And all output connectors will have that voltage. Basic USB needs 5 volts. The LED light can get all the power it needs, and the light does not flicker. The voltage is a wee bit high, should be no more than 5.25 volts, but not to worry, I think. The big question is, can I charge a smartphone? The answer is, maybe. Here you see it is working and producing only 2.42 watt, but I promise you that charging directly either sucks or does not work at all. Power coming from cranking my arm is not that much and not constant enough. The better practice is to first charge a small to medium sized power bank and then let that charge your phone. This phone, how much power does it want at 5 volts? 9.5 watts. That is a lot more than the 2.4 watt coming from the good quality generator. Time for another reality check. Using the good quality ARM generator to charge my phone would take 3 hours and 43 minutes. Nobody wants to crank for more than 3 hours to partly charge the phone. To reduce the time, we need to increase the power. Next conclusion. Cranking by arm works, but charging a phone with only 2.5 watts is problematic and takes too much time. I do believe that a more efficient generator may reach 8 watts. That would be much better. While searching the web for hand crank generators, I ran into these emergency radios that have a generator and many other functions. Will these be efficient and powerful enough to charge my phone? It is a bit off topic, but let me show you all the functions of the emergency radio that I bought. Oh yeah, what's more, nothing in this video is sponsored. Cranking my arm to generate electricity is no fun. It is something you need to do when there is no alternative. So the generator of an emergency radio should be powerful and efficient. If an emergency radio has a good generator, then the whole thing is just a sweet package of many emergency essentials. Possibly for the same price as just one good generator. So yeah, I really like this little yellow emergency radio. But the question is, can it charge a phone? And how good is the generator? The USB output voltage is good. Good until you charge the phone. It does charge the phone, but with only 2 watts. Time for another reality check. We need to produce 9 watt-hours, but the battery can only hold 3. How long will it take to fully charge this battery 3 times? Instead of cranking for hours, we can simply place it outside in direct sunlight and let the solar panel charge the battery. When full, charge the phone for 1/3 and repeat this 2 more times. After 3 days, melting in full summer sunlight, the phone will be charged. Remember though to in the meantime, not use the emergency radio nor your phone. These tiny solar panels on emergency radios can charge the battery only extremely slowly. And to be fair, a large enough solar panel does not fit on it. The emergency radio solar panel is about 0.5 watts, maximum. If you want to charge this radio or a real power bank with solar, you need a much larger solar panel surface. This small solar book is 20 times larger. And this, one size bigger, is 57 times more powerful. Back to cranking. How much power can this one generate? When testing the LED light from the battery, the voltage is good and it uses 1.61 watts. When taking out the battery and cranking by arm, the voltage is good. But when trying to power the LED, the voltage drops to a useless 3.26 volts. And the ampere is near to 0. Is this not a proper way to test it? I was expecting 2 watts. My conclusion? I am disappointed. It is a nice rugged radio, but its best features should be the hand crank generator, the solar and the power bank. But they are all too weak, like a toy. And all those cheaper ones I've seen on the market will probably be even worse. There are 2 ways to improve this emergency radio. Add 20 times more solar, use a better battery, but the hand crank generator is what it is. The original battery is only 3.15 watt-hours. You can replace this. I had these 2 options, none of them fit. The protected one is simply too high. The biggest capacity, 5.18 watt-hours, has no button top. But this trick seems to work. Put a tiny magnet on top, a strong silver one. This worked for me. Instead of an all-in-one emergency radio, you can also get it all separate. 20 times more solar, a mini radio, a good power bank, also battery charger, and a good practical flashlight. Now instead of 5 watt-hours, you have 52 watt-hours. Altogether costs about the same as the emergency radio. Or, if you can afford a bit more, get the 20 times more solar, a better radio, a much better flashlight, also camping light, and the better power bank, also battery charger. Now instead of 5 watt-hours, you have 68 watt-hours. Also, there's easy access to all of the batteries. Let's compare the power bank function. Remember the emergency radio? It charged with 2.1 watts. Now this power bank battery charger, 11.4 watts. That's so much better. Or what if you buy one of the best and most expensive emergency radios? And of course, 20 times more solar. This emergency radio seems to have the best hand crank generator on the whole market. Also is it better in almost any way relative to its little yellow brother. The little yellow has an arm of only 6.3 centimeters. This is too small, really. The big blue has an arm of 10.5 centimeters. That could be enough. The battery is bigger, though not big enough. And what is a deal breaker to me, the battery isn't built in. There's no access to it. I hate that. In order to check the quality of the generator, we have to take it apart. But that's a stupid idea, because we could break this expensive emergency radio and definitely its warranty. I will fast forward most of this teardown. What I can say is that most of this thing is really good. The radio, the sound in and out, can be used as a Bluetooth speaker. The lights and emergency sound are good. The outside not just looks rugged, it is rugged. Ta-da, it's open. My first impression, it looks very well made. So where are the battery and the generator? In here must be the gears and the generator. And next to it is hidden just one 18650 lithium-ion battery cell. You can see 3 wires going to the motherboard, where there are 6 diodes, telling us that the generator is a brushless 3-phase. That is good news. Now let's take a closer look at the gears and the generator. Oh my, this is not looking good. The generator is tiny, the plastic gears are too small. It is well weather protected and oiled, but look, just 4 tiny screws on 4 little plastic poles. This will not last long. There's no easy way to measure the power and efficiency of this generator. It is brushless and it does spin fast. By feeling and comparing to other generators, we guess it generates a maximum of only 3 watts. My advice is to not buy any all-in-one emergency radio, because even the best on the market are not good enough to be useful in case of an emergency. The blue one is a nice rugged radio, but 0.5 watt solar, 3 watt cranking, 9.5 watt hour power bank. Come on, this is toy territory. A message to the manufacturers of emergency radios. Please make one that we can take seriously. Do not add a solar panel to it. It will never be large enough. The hand crank generator should be a durable module producing around 8 watts. Do not build in the battery. Give easy access to the battery. Use at least one lithium-ion 21700 battery cell. It seems that there are hardly any good quality arm crank generators on the worldwide market. So we better make it ourselves. That's more fun anyways. To set a goal, I think it's possible to generate 8 watts with one arm and with ease. Let us start here. A toy car motor plus part of the wheel. This brushed DC motor runs as a motor when putting 12 volt DC on it. But when you turn a wheel, the motor becomes a generator. Here the dirty electricity goes through a full bridge rectifier. No matter what direction you turn, the output polarity is always correct. Then there's a capacitor. It is like a bucket for the electrons, making the output more clean and smooth. First, gears to increase the RPM of the generator, then a rectifier that works in both directions, then a capacitor to make it smooth, then a DC to DC step down to 5 volts USB. .3 volts is a good input voltage, but there's no load connected yet. With a small load connected, some LEDs, it produces only 0.85 watts. We want at least 3 watts. With another small load connected, a small power bank, it produces even less, only 0.6 watts. These are two strong neodymium magnets. I know this trick that works on low quality motors. These can increase the magnetic field inside the motor. Be sure to place them aligned to the existing field. With no load we had 7.3 volts. Now we have 10.5. With a load we had 0.8 watts. Now we have 1.44 watts. Much better, but no 3 watts yet. Can we charge a phone already? Well, a little bit. Too little really. How can we produce more watts? We can make it larger and more efficient. Use a bigger motor, a brushless motor instead of brushed, increase the RPM, use less gears, use Schottky diodes, and use a flywheel. First one was too small. Here's the second one. Bigger. And bigger is the biggest difference here. I kept the magnets, but they do very little because this motor is better. Then added one ferrite ring to reduce the noise, but I have no oscilloscope, so no clue really on how dirty this electricity is. The first test is also a test to see if the system works without a capacitor, as the DC to DC USB has those on board already. The voltage without a load is good, but with a small load, some LEDs, the power is not constant at all. And with a bigger load, more LEDs, the power collapses all the time, and the power readout is impossible. Thus clearly, a beefy capacitor is needed on the output of the generator. Now the small LED light shines constant. It gets 1.15 watt, which is enough power, and we can now read the display. The large LED light, it has improved, but it is not good enough yet. These are 3 supercapacitors. And here they are together in series to increase the maximum voltage. Now the large LED light shines without flickering and the power used can be read. Note that the goal of the power by arm was at least 3 watts. We are now at 6 watts. A small power bank can be charged, no problem. A smartphone? Well, yes, but not long without troubles. It's still better to first charge a power bank and then charge your phone with that power bank. Okay, where are we? To generate electricity with just one hand is just a waste of time. To generate electricity with just one arm is okay. You can make it yourself, aim for at least 6 watts. I think around 10 watts is the maximum. Now it is time to step up the power. Move to from 2 legs. So we went to the second-hand store and bought this old exercise bike. Why this one? Because it's small and very important, it has a flywheel. Here you can see the inside already. It looks good at first, but if you look longer, you'll find there's a lot of work to do. The dirty chain we can clean. The bad bearings, I'm not sure if we can fix that. The magnetic brake is very interesting, but we have to take it out, because it gives quite some resistance, even on its lowest setting. There is an aluminum strip on the inside of the flywheel. The closer the magnets get to the aluminum, the stronger the magnetic forces from the magnets and the aluminum work against each other to slow down the flywheel. We removed all that is not necessary, cleaned and oiled the chain, and now it runs with way less resistance. We glued a rubber strip on the outside of the flywheel so that a brushless outrunner motor can be driven by it, becoming a generator. This setup is super simple. One brushless outrunner, one rectifier for 3-phase, and 2 DC to USB electronics. Check out how useful the flywheel is, how long it continues with a small load. One more thing that is actually essential is a voltmeter, connected to the output of the rectifier. Now let's figure out how much power we can generate with 2 legs. These 2 DC to USB boards could power the power banks with a maximum of 10 watts each, but we want more power. This board has 4 outputs with quick charge protocols. It can deliver much more power. But there's a problem, a bottleneck. The brushless outrunner loses grip at about 30 watts and its voltage is quite low. I found a much better motor. It has 3 times the width, smooth rubber on the outside. It should be able to transfer 3 times the energy. It is a brushless outrunner from an electric skateboard. More grip, more ampere and a higher voltage. The output voltage is good and it is super easy to power a light load by hand. The small LED light gets enough power easily. The larger LED light is also easy to power. Charging the phone goes well. Note how the quick charge protocol has selected 9 volts instead of 5. Power bank goes well, but we have reached the limit of what we can generate by one arm, more than 11 watts. Two power banks. They charge, but suboptimal, because this arm is getting tired. So we switched from one arm to using 2 legs. And now it's a piece of cake to charge the 2 power banks. 15 watts. It's like no effort. Two power banks, 1 phone and 1 LED light. Around 32 watts. This resistance you do notice compared to riding a city bike at normal tempo. Most people can bike this tempo for 1 hour, which generates 32 watt hour. I noticed that the 2 power banks were not charging at the same rate. Why is that? Maybe one of the USB cables is bad. To be honest, I thought that USB cables with equal connectors would be equal in capabilities, but it turns out that's not the case. Here, for example, a charger with a USB wire and a power bank. It charges with 4.9 volts. Now I only change the wire and see, now it charges with 11.6 volts. We have to talk about USB cables for power transfer because that can be the bottleneck. There are good quality and bad quality USB cables. You never know really which is which, even if it was expensive, so you have to test it with a USB tester. There are protocols for USB-C connectors and protocols for older connectors. USB-C can transfer more power than the older standards. Short cables are better at transferring power and better at transferring data. So use short, not long. There are normal cables and charge cables. Normal cables do data and power. Charge cables do only power, but they do the power part extra well. Test it with a USB tester. There are smart and dumb USB-C cables. Smart USB-C cables have an eMark chip inside.
Hi, I'm smart. I can handle 5 ampere, 48 volts.
They can handle up to 5 ampere times 48 volts is 240 watts. Dumb USB-C cables get no more than 3 ampere times 20 volts is 60 watts. Altogether, for maximum power transfer over USB, use a good quality smart USB-C cable, a short cable that can handle 5 ampere, and always use a USB tester to see what is really happening. Remember the good quality generator? It was charging the phone with only 2.42 watts, using basic USB-A. Here we use the same generator, but now connected to a DC to USB-C converter and a good USB-C wire. The difference is enormous, 8 watts, which is 3.3 times more. A similar story with the Selfmade generator. That was 4.5 watts and now 9 watts using USB-C. Now the USB bottleneck is solved, we can continue generating more power with 2 legs. Charging 2 large power banks at the same time is easy. With these quick charge power delivery and MPPT protocols, there is a buildup of power. Here we start at 10 watts and slowly it goes up to 40 watts. Now we get to the best way to generate and store the most power. Not just a power bank, this is a modern lithium iron phosphate battery that can charge with 144 watts constantly. This battery charger is a modern and efficient MPPT solar charge controller that works with lithium iron phosphate. It is one size too large at 24 volt input. It can handle 720 watts, but this is what I had left over from a solar project. Get one with Bluetooth, so you can monitor on your phone what exactly is happening. MPPT can be annoying, as in it searches for the optimal power, and by doing so the resistance of your bike changes a lot. When you start to cycle, the charge controller gives you no resistance at first, but you'll know when it kicks in, because it becomes heavier and heavier to cycle. You will probably get to the point where you feel the charge controller is asking too much. A solution for that is to set a maximum charge current. Now it will stop increasing the power at that level. Here you can see a typical ramp up of an MPPT charge controller. It starts with no resistance, no power. Then it starts taking power a little, then more, up to the maximum you can give, or up to the maximum level you have set. How much power can you create this way? That depends on how fit you are. But I guess that most people can do 60 watts for 30 minutes, no problem. And that makes 30 watt hours. "100 watts, a nice number to close this adventure and go to the conclusions. So once more, we want to produce 9 watt hours to charge a mobile phone from 20 to 80%. Producing electricity by hand, well, gives you 1 watt or less. That's useless, it takes too long, it's too little. Producing electricity by arm is okay. Expect around 8 watts. It will take you a long time, but it's okay for an emergency, also because it's mobile. Producing electricity with your legs, that's of course the clear winner, but the generator is less mobile. At a pretty easy tempo, biking, you generate 60 watts, do that for just 9 minutes, and there you have your 9 watt hours. Hey all, you made it all the way until the end. Me too, this was a long video. I started it in 2015. It's almost 2024. But it was a lot of fun. Of course, I could not have done this all by myself. I got a lot of help from Doris and Tanaj. You may think, what's that thing on my forehead? It's not religious, it's how I control my computer. It's a head mouse. So there are not many good ARM generators that you can buy online. We made one, it works okay. It's not good enough, I think we can do better. But I thought, let's make it into a contest. For anybody who's interested, try to make one that's better than the one we made and post it online on YouTube. Then we can compare, and then then everybody can make a better one themselves. How about that? Okay, well, have fun making stuff, and I'll see you in the next video. Bye!